Thanks for hanging in the middle of the post-lunch slump. We've had a great conference so far, digging deep into the quantitative side with from the data cleaning and correction that we just talked about through targeting, advanced targeting, activation, attribution modeling. Now we're going to kind of take a left turn and talk about something a little bit more intuitive. It's data visualization. So it is a step in data science. It's defined as producing a new insight by bringing together a key aspect and showing it in a more intuitive way. So in order to do that, you have to have a balance between kind of functionality and providing the right data and deriving the insight, and also kind of aesthetics or beauty, a way to kind of bring it up where it's easy to grasp and also engages the audience and gets them to talk about it and actually pay attention to it. So that's the challenge of today, and we've got some great cases from MapQuest. So our presenter is going to be Elise Neel. She's been in the digital realm for quite some time, had a variety of different roles, and is now the head of sales at MapQuest. She's going to take us through a couple of cases of how they use their data in visualization, and then we'll open it up for some questions for both Elise and Brian McMahon, who's also from MapQuest.
Hey guys, I hope you're excited to see some pretty pictures today, because we came ready to show some to you. So as a start, if you're not familiar with MapQuest, just a quick snippet on kind of who we are. We're the second largest mapping provider in the United States. We're wholly owned by AOL and have been since about 1999. We have 45 million users on our consumer side that primarily reside within the United States and Canada. And from that, we have an application across desktop, tablet, mobile web, and native application that basically promotes local discovery and navigation. So we physically move humans through space and time through the MapQuest applications and services that we have. In addition to that, we also have an enterprise stack, which is a global enterprise stack. It's a suite of about a dozen different APIs built for every platform and plugin that are all kind of geospatial in nature. And so as we think about data visualization, we realized quite some time ago that we were sitting on some really, really interesting location data. And a couple years ago, before kind of folks started getting on the location bandwagon, the folks at AOL and Brian here at MapQuest really took an advanced step and said, before we even start thinking about this, we need to make sure that we've got a couple things in check. So we spent about a year hanging out with the legal and privacy guys, doing a lot of external counsel and making sure that we could not only legally, but also that we were really responsible in the way that we could collect the information passively, that we were very upfront with our users, that we provided a series of opt-outs and communication about the types of data that we were collecting on them, not only from a user perspective, but also potentially for an enterprise use case moving forward. And so with that, for the last 6 months, we've been doing some interesting things on the data side. So a quick summary, the first thing we do is we collect all the destinations that our users search for. So it happens about 250 million location-enabled searches every day that are attached to a cookie or a device ID. It's all anonymized. There's no login that's attributed here, so it's all anonymous data. The second data point that we have is our routing data. So we look at all of the starts and ends. So I'm starting at San Sebastian and I'm going to the Pinchos. I'm still working on that one, Pinchos bar, and the way path kind of connecting through there. And then the last data set that we collect is all of the mobile GPS data. So these are second by second data points, and we collect a number of attributes: lat long, timestamp, device ID, speed, bearing, altitude, etc. And mostly these are used for the consumer purpose as that little blue dot that gently guides you along the way and says, you've made a wrong turn, let's go back and re-navigate a different way. But obviously for marketers and advertisers and researchers, that data could mean something very, very different. So when we started thinking about data visualization and how in the world we were going to communicate this billions and billions of data points in very, very small spaces, I was enjoying Sean's presentation earlier today of trying to keep it simple. And we could either we had one of two options. You kind of show up and throw up, just like, here's all the data and here's what it is. Or you can start showing some pretty pictures. So we started pretty easy, and we said, okay, what does our data look like in a flat version? And so actually this shows the animated, which is the second thing that we created. So basically we said, hey, look, let's step one, look at clarity and coverage. We want to communicate this to our customers. How can we do that in a meaningful way? We then kind of graduated into movies, and that graduation from a flat visual to something that's animated is actually very, very complicated with the volume of data that we have. And so if you want to actually tee up the next video, I think I saw it up there. It actually animates the coverage. So what you're looking at in this next visual is, do you want to tee that back up again, gentlemen? What you're looking at is 1 day's worth of our data in the whole of the United States. So the aim here is, again, to show clarity, coverage, scale. People say, what does 45 million devices look like? If there's 120 million households, is that nationally representative? And what we found through the data is that it actually mirrors almost identical the actual internet footprint of the United States. We were like, all right, we're looking good. And then the next step after that is we started taking it to clients. So the first case study I'm going to walk you through is for Papa John's. If you are not familiar with Papa John's, we Americans take our pizza very seriously. And these guys are one of the top pizza producers. They have about 4,500 franchise locations in the United States, and they're also our global operation as well. And we said, hey, we have all this location data. Is this interesting? And they said, I think you can solve a problem for me. Here's my problem. We have 4,500 franchises. They all want more marketing money. They all think that there's some difference between the amount of foot traffic they get and the amount of pizzas that they deliver. Can you help us solve the problem? So we said, sure. So we started with a couple examples. Actually, this is going a little quick. So the first piece we did was we said, let's take all of our GPS trace data, just our mobile data, and let's begin to plot it by store. So what you're looking at in this visual over satellite imagery, the purple routes indicate routes that are ending, MapQuest users' routes that are ending at a Papa John's. So it says I'm coming from work, I'm coming from home, I'm coming from a play date, I'm coming from wherever. And then inversely, the blue lines indicate those routes that have started at a Papa John's and going somewhere else. So Papa John's is trying to figure out, where does the notion of I want pizza for dinner, where does that fall into a consumer's life? And there's a couple ways that you can do it. You can begin to create bar charts and graphs and tables, or you can start plotting it by franchise location over satellite imagery or regular mapping, and you can begin to create a whole nother context. How far are they driving? Is it a school? Is it a military facility? Is it a home? Is it a residence? Is it within a neighborhood, etc.? The next thing they asked us to do, they were like, this looks really cool. We want more information. Can you do this for all of our stores? And our challenge is we're trying to evaluate whether or not we need to reevaluate the boundaries of our trade areas. So within each of their franchise locations, they have polygonal structures, or kind of circles, if you will, that says for that particular franchise location, I can only deliver pizzas to the people that live within this circle spot. So we said, no problem, we'll certainly do that. So what we did for them was we built them a GUI, an interface that takes in live mobile location data from just MapQuest users, so all of our first-party data. It's not combined with Papa John's data at all. We put that base map, our MapQuest API base map underneath. We ingested their points of interest, which are their franchise locations. We ingested the polygonal structures. And now what they can do is scroll by store to see how the traffic correlates and people move between all of the trade areas. You see, if you work 50 miles away from where you live, you might decide from work that you have made no plans for dinner that night, and you want to pick up a pizza on the way home, but you're passing through 16 trade areas on the way home. Where do you get your pizza from? Who gets the credit for that? And so how can they think creatively about ways that they might want to redo their trade areas? So we provided them the interface. They use it today. It's really interesting, and it'll be fun to see kind of how they change their business as a result of just using visualization as a powerful tool. Today I was supposed to be joined by a gentleman named Tom Filand, who's the CMO of Kroenke Sports Entertainment. Kroenke Sports, if you're not familiar, this is like a man's job. They own a number of American sports teams and stadiums, so he's like the guy you always want to hang out with at the bar, and unfortunately he was taken away with some family business. But basically, they own the St. Louis Rams, which is an American football team. They own a team for MLS. They own a team for the NHL, lacrosse, etc., basketball. They also own a number of stadiums. You might be familiar. In the international audience, they are the #1 shareholder for Arsenal, the English football team. And so when we went to Kroenke, we said, all right, what can we do for you? How can we partner? And they said, we have a bunch of these stadium locations, one of which is the Pepsi Center, which is located in Denver, Colorado. And they said Tom's particular job is to make sure that when they acquire a sponsor for their stadium, it's not born the Pepsi Center. Pepsi obviously had to pay millions of dollars to put their moniker on it. He also looks at all of the other in-stadium advertising. And he said, the challenge is I'm asking these people to spend millions of dollars with me every year and then kind of go, I hope it works. And there's no real correlation between someone's exposure inside the stadium and then what they do afterwards. And he said, I feel like you guys can help me out. And we were like, Of course, Tom. Like, we got you hooked up for a couple tickets. No problem. We'll get you going. I'm kidding, kind of. So in this next video, I don't know, we had some trouble with this one before, but again, we kind of start with this baseline of, help me understand, do we have enough clarity and coverage within that particular area? Looks like this video isn't quite gonna work, but effectively what we do is we plot all of the data on a white background to look for clarity and coverage, just to say, do we even have enough data in this area to make it work? Thankfully, we had a ton of coverage within the Denver market, and so we took it to the next step. And actually, if you tee up the next video for the Pepsi Center, I'll walk you through the more advanced analysis that we did for them. So in this next video, what you're gonna see is a red box. It's a rectangle. That's the bounding box that is where the Pepsi Center in Denver, Colorado sits. And what we took was, we said, tell me all of the devices that have entered into this bounding box, all the mobile devices, and let's look at where they go after the game. So where do they go? We flag them by points of interest so we can see the relative area in which they visit these areas. So what you can see here is obviously they're going to restaurants, they're going shopping, they're going to bars and clubs, etc. If you're familiar with the Denver area and where this is situated, spatial context is obviously important. South of this is the University of Colorado. This is a huge walking town. So in here to the right is a huge area that's filled with local bars and restaurants and things like that. So after the game is over, people just pour out into the streets. They're walking to their cars, which are multiple blocks away, and they're spending money in all of the surrounding areas. So Tom says, okay, great. Well, this tells me a couple things. One, it tells me I need to rejigger some of my parking stuff, right? I need to rethink about some of that movement. The second thing it tells me is, instead of going after all of these big brands to spend $5, $10, $15 million with us, I also need to be talking to local businesses, because I can directly correlate the fact that when I have 50,000 people locked up for a bad football game and people want to then pour out into the streets to go spend money, I can help get them there, right? I have an exposure mechanism to make sure that they're top of mind when they leave the stadium. The last example I'm going to show you, if you want to tee up the final video, is for the St. Louis Rams, which is the Edward Jones Dome. And St. Louis is a very different city than Denver, Colorado. So when you begin to take these concepts into play, you can look at the local surrounding areas to then create correlations just through the visualization. So using the same bounding box, what you can see, it's towards the middle there. You can see a couple things. You see the red icon with the white cross. A couple people visited the hospital. Looks like it was a little bit of a rough football game that day. So we got some hospital visits in there. There's more lodging, ATMs, bars, restaurants, etc. There's the little blue icon that looks like a capital in it. That north of the stadium is the Traffic Violations Bureau. Those are people who have illegally parked, have a boot on their car has been towed, maybe they spent a little bit too much time after the game and now need to go kind of rescue their belongings, if you will. So we learned a couple things from these different visualizations, and I'll wrap up with this. If you want to go back to the slide, there's kind of 3 big points. The first is, as people, we have 2 legs, 2 arms, we move. We pace, we breathe, we move through life. So if we are going to do an analysis of how consumers move, perhaps our analysis of them should move as well. And that was a huge kind of awakening to Tom going, shoot, I'm looking at this from bars and charts and pies, and maybe the perspective that I'm going to get from looking at it from a movie perspective, as people come in and out of my stadiums, or in and out of my retail locations, or in and around their local communities, what is that going to tell me that's different? The second is that the application of the data has gotten really interesting. It's not just about, a marketing use case or whether or not your franchise location is being accessed. It's about parking. It's about hedge funds. It's about, local businesses and things like that. And the last is we're just at the beginning. This is the beginning of data visualization and location. And so with that, I guess we'll turn it over to questions. Just kidding. We have to wrap up.
We're going to wrap up. Thank you.